Thank you. Today I'll be talking about some of the lower food web work that we're doing. Just a real quick overview in case you don't know where we do this work. This work is based on some long-term research projects, and these primarily take place in southern Lake Michigan along a transect off Muskegon, Michigan. And the data goes back to the 70s or 80s for the offshore work, and then we started some nearshore work in the mid to late 90s. And it's lower food web stuff. The primary components of that: nutrients, zooplankton, mysis, chlorophyll. And we also have been more recently doing some mooring work where we've been occupying these stations, doing moorings, looking at currents, water temperature, transparency, and fluorometry. And some of this goes back a ways as well, but more recently we've been doing some overwinter moorings, trying to get some data from that overwinter period. So just because weather, especially this morning as you've come in, has been pretty interesting, and we think about last year, what it was like when we were at the Fish Commission meeting, how warm it was during that period. Just wanted to show you some of our overwinter water temperature mooring. And here we have the top line would be the red line is the surface temperature, the blue line is the bottom temperature where we had thermistors. You can see in 2010, 2011 where the surface temperatures gradually cool down. In December, January, it mixes where it's the same top to bottom. And that's when we think the mussels have their biggest impact in the offshore directly, because they're connected to the whole water column. It's isothermal. Pointer here. So right through here, it's mixed, top to bottom, it's mixed. And then actually you can see in this year, it got fairly cold. In March, the water temperatures were about 1 degree. You compare that to last year, it took a long time for it to mix. It was actually pretty warm. Went in and out of mixing with storms through the winter. Really wasn't mixed that much. And then here's when we were meeting last year in March. We were warming up. Actually, it was starting to stratify in March. That's really, really unusual. But we did have a storm, mixed it back down, it was all mixed together, and actually April was pretty cool, and it didn't really stratify again until about May, which is still fairly early. This year, if you're wondering, it took a long time actually for it to mix. We were out actually in January this year. It's hard to remember, but January was still actually fairly nice in southern Lake Michigan. Water temperatures at the surface were still about 6 to 7 degrees then. Right now we're in between these 2 years about. The water temperatures really aren't that cold despite the wonderful last few months that we've been having. They're around 3 degrees right now, so they're not on the colder end. They're kind of in between these 2 years here. So they're still a little bit warm. Like I said, we also had fluorometers out there to see what's going on with the chlorophyll. We use the fluorometers as a measure of chlorophyll. What I want to point out here is here's where we had that warming up in March. And you can see we actually started to build up some chlorophyll in the lake right then. But then we had the storm, and what we think is this is where the mussels were able to kind of peel that all back out. So it looked like we were maybe going to get a spring bloom here. March would be very early for a spring bloom, but March is also early for it to be stratified. But we got that storm, mixed it all back together, and we think the mussels were able to clear that all out. This is kind of hard, weird data to work with, so we're working with the physical oceanographers at our lab to look at this data, wind data, water temperature data, and this chlorophyll data to try and get a better understanding of what's going on in the lake. When we sample, the other thing to keep in mind is just how dynamic it is. When we sample chlorophyll, we sampled here, and we sampled here, and we weren't on the lake here. Had we been on the lake here, doing our extracted samples, we'd have a different idea maybe of what chlorophyll would be like in our sampling. So it just gives you an idea how dynamic things are during the early winter or the early spring. We've had a lot of retirements here, so I don't have a lot of new information to give you on the mussel condition. Tom Nalepa has retired. He's still working with us through U of M, but like he told me, he's like, Steve, I'm retired. Things go a lot slower now. And I'm surprised he works at all, but it's Tom, right? But we did do a southern Lake Huron or Lake Michigan survey in 2012. Those samples haven't been counted yet. We were also doing Lake Huron. That's kind of taken a priority. But looking at the numbers of mussels for 2011 and 2012, it looks like the trend we showed last year where the mussels are stabilizing in those nearshore areas is continuing, whereas in the offshore areas it looks like mussel numbers are continuing to increase. And I don't think any reason why that would have changed last year. So one of the main things that we think that the mussels were related to were this decline in the spring bloom, where the chlorophyll would be increasing from March, April into a real peak in May. And you can see where this is, I lost my years. There were years on the original, I swear. Whoops. This would be 2012. And so you can see these last few years since 2007, there's really been no return of the spring bloom. It's been low, where we're basically down below 1 microgram per liter. This 2010, if you can remember that spring, we had about 2-3 weeks in March where it was just dead calm, fairly warm. We had that layer that formed up on top. We sampled during that layer, so we got a little bit of a higher chlorophyll in that year. So that's like what I showed, that peak from last winter. We sampled during one of those peaks. It was also washed out by April and May, but in the average, it looks like we have a little bit of bump up there. But really no return of the spring bloom for our 2012 data. When the water stratifies in the summer, things get a little bit more complicated when you're looking at the chlorophyll. In the spring, it's the same, top to bottom. Water's mixed, the chlorophyll's mixed. In the summer, we start to get some layers. Up near the top, we get this surface mixed layer. Then we get this deep chlorophyll layer, subepigenetic. This would be the deep chlorophyll maximum. And then what we call, lost all sorts of numbers here. This layer right here is what we call the deep chlorophyll layer, anything greater than 2 micrograms per liter. So we integrate that area and measure that. So that's the measure of the size of the deep chlorophyll layer. And then right here is the nephloid region. And part of that, there's chlorophyll in that region. This deep chlorophyll layer forms when the spring, especially the spring diatoms, would settle out of the spring bloom, settle below that, the epilimnion, and grow. There's other factors that contributed to it, but that was the big part of it. This chlorophyll in this nephloid regions, it's comprised because there's settling, there's resuspension, and then there's also nearshore to offshore transport of material. To do this, we're using CTD, fluorometer data, to get this profile, and then we calibrate it with extracted chlorophylls, just so we can look at that structure. So we'll start out with the easy layers. The surface mixed layer, that top layer in the epilimnion, in early and late summer, we really didn't see any changes from the 90s to now. It just really hasn't changed that much. We think this area's got a lot of regeneration. It's got higher temperatures, the activity's pretty fast, and we think that's maybe why nothing's really changed in that top layer. That's maybe surprising when we think about what happened to our spring bloom. Remember, the spring bloom is settling out, so maybe that's not what's part of that surface mixed layer. If we go to the next easy one, the near bottom region, where we had chlorophyll in that nephloid region, completely different from what we see in that surface mixed layer, where we see big declines in the chlorophyll in that near bottom region in both early and late summer. If you think about what forms that region, it's settling of material, there's less material settling, it's transport of material from the near shore. Well, obviously all of that's getting filtered by all the mussels in the near shore region, and then also this region's always touching the mussels in the bottom of the lake, so it's always being filtered. Unlike that surface mixed layer, it's separated from the mussels during the summer. Oh, I lost my pic. I lost my slide here. Well, you can see where that should be. There's the point. So in the summer, this is where our deep chlorophyll layer was. In the early summer, it's fallen down to here. In late summer, we don't see any change. The early summer is when you have your deep chlorophyll layer, June and July. Late summer, it's kind of declining already, so we don't see any change then. Here, whereas the average deep chlorophyll layer was up here, here's where it is now. So this is a layer that depended on that spring bloom. It needed that material to settle out and to grow into in that deep layer. This will show it a little bit. Here's the average by year, and you can see It's been fairly low all these last years. Here's 2012. Maybe it ticked up a little bit, but it's still low. Really no deep chlorophyll layer at all to speak of. And for this, we also have some data from the 80s. This isn't fluorometer data. This is when Gary and Don Scavia just took a whole bunch of water samples through the water column. So this is all extracted chlorophyll. You can see it's pretty much the same as it was in the late 80s. It was fairly high in the late 90s. It was fairly high. The real high years were these mid 90s years. But there's really not much of a deep chlorophyll layer right now. Now that's not to say there's not elevated chlorophyll. If you looked at a profile, you'd say, Steve, you're crazy. There's still a layer down there, right? That's not to say there isn't a layer. It's just, it's narrower. The peak isn't as high. The deep chlorophyll maximum isn't as high if you integrate below 2. See how small of an area that is. And the other thing to keep in mind is we have a lot more light in the system. It's also deeper. So it's deeper in the water column than it used to be. So you would think with more light, you should get a bigger deep chlorophyll layer, right? That's one of the reasons. But keep in mind, there's a couple things going on. One is, I talked about the spring. Here's your connection to spring. If you don't have spring chlorophyll, you don't get a real big deep chlorophyll layer. You need something to go down there and grow. The other thing is nutrients. Now, Lake Superior has had historically more light than Lake Michigan, but it didn't have as big a deep chlorophyll layer as Lake Michigan. Why? It didn't have the nutrients that Lake Michigan had. And now we're seeing their deep chlorophyll layers are more similar. The interesting thing is we see similar rates of decline in phosphorus in the early summer in all 3 of those layers. It doesn't seem to affect that surface mixed layer as much, probably because there's more regeneration of nutrients up in that layer. Whereas in these other layers, it seems to be affecting it more. Next, we'll move into some of the offshore stuff. We kind of ignore into the nearshore stuff. We kind of ignore the nearshore because it's a lot harder to work with. Our data set doesn't go back as far. But this is chlorophyll from the nearshore. You can see how variable it is during the year. This Muskegon station has a river influence, and so we get a big push of chlorophyll in the spring in May and June. You also can see some variation between years. It's a little bit lower in 2012 compared to some of the previous years. Gary did some primary production. I think this is for 2009, the red primary production at that nearshore station, and he compared it to that region in the 1970s. And you can see we think of the nearshore as being a super productive area yet, but compared to the 70s, it's not. Gary estimates it's between 50 and in some periods 70% lower than it was in the 70s. A lot's happened since the 70s, so that's not surprising, but maybe we sometimes think of the nearshore as maybe a more productive region than it really is. Comparing that, the chlorophyll at the 15 meter to our 110 meter station, you can see it during a lot of the year, it's not that much different during late summer and into the fall. And at this Muskegon station, only in that spring when we get that push out of the river do we see the relatively high chlorophyll at the nearshore compared to the offshore. If we were at a station maybe like off Frankfurt, we don't see this big push because you don't have that river influence there. So it'd be even more similar between nearshore and offshore there. Now I hesitated to use this slide that Gary gave me because in his retirement he's gone crazy with his colors and I couldn't change them. But this shows the primary production in 2009 at all 3 of those stations. And so I thought it was important to make the point you really don't see, if you can see, you really don't see a big gradient in primary production between the 1545 and the 110 meter station during this year. So really that nearshore station isn't an epicenter of production like sometimes that we think that it is compared to the offshore right now. Next, jumping into some of our zooplankton data. This is the offshore data. A couple things to point out. One is there's really no increasing or decreasing trend from the 90s through 2012. We saw some changes in the composition here. We saw like this early 2007, 2008, we saw the cyclopoids were gone and very low Daphnia. Whereas now, the last few years, we've seen Daphnia coming back and we've seen the cyclopoids recovering. Now this is taking all the year's data and compressing it into an annual mean, and there's a lot of reasons not to do that, but it makes it a lot easier to look at for something like this, and we can see the composition. But it's somewhat surprising maybe that these Daphnia are coming back right here. If you think about the lower food web things going on, you would think that they should be getting squeezed. We've lost our deep chlorophyll layer. We don't have the spring bloom. although our summer and our surface mixed layer chlorophylls seem to be holding on, late summer. On the other hand, maybe you're surprised that they aren't higher because the fish numbers are so low in the lake and there's nothing out there to eat them, so they should be increasing higher. So maybe the low primary production and the low fish predation are balancing out, and we don't have any huge changes in the zooplankton in the offshore. Calanoid copepods are the main zooplankton out there, so we wanted to look at those and just see what's going on with them. They're mostly diaptomid copepods. The other one that's out there are the limnicalinus. And we really, this black is limnicalinus, we really don't see any increasing or decreasing trends in limnicalinus over time. They're the great big calanoid copepods, so a lot of things like to eat them. But they're really not increasing or decreasing. Finally, the nearshore zooplankton, without ears. This goes through 2011. We haven't done the new samples yet. But you can see, well, you can't, but the yellow is Daphnia. And the Daphnia really aren't a big player in the nearshore zooplankton community because there's more fish there, there's more fish predation there, so you don't get bigger cladocerans. The blue is Bosmina, so the real small cladocerans. So you tend to have more small cladocerans where you have fish predation. You also see this kind of kickback where you have this recovery of cyclopoids in the nearshore region. But again, no real overall decreasing or increasing trend in zooplankton in the nearshore region. Again, comparing that nearshore to offshore, again, just to show, we don't see any huge difference between the nearshore and the offshore zooplankton biomass. And that's maybe somewhat surprising. And the other thing to keep in mind is this is on a volumetric basis. So if you turned it to an absolute number, you're dividing that number by 1,000 or by 100 at the 110 meter station by 110 and only by 15. So in terms of absolute numbers, the absolute numbers are actually higher offshore than they would be at the nearshore station. So it's not like the nearshore is this epicenter of production for zooplankton either. Finally, looking at the mysis numbers, this is for the offshore mysis numbers. This is the annual mean. You can see we were kind of ticking up here a little bit, and then this year we had fairly low numbers, probably the lowest numbers we have since the mid-90s. So it's not sure if this is low like 2007 was low and then we're going to come back up, or if we're low for other reasons. It's surprising that mysis are so low because there's so few fish in the lake. It's also not surprising that they're low because the few fish that are in the lake have to eat mysis because there's no diparia. The other thing is without a deep chlorophyll layer, that's where mysis used to feed. Mysis would feed in that detrital layer in that nephloid region, which is also gone. So where they eat, those things are being squeezed out too. So mysis are probably being squeezed even though fish predation is fairly low in terms of numbers. But if they'll be like this in the next couple of years, or if we're just down here, that's hard to tell. So just conclusions, we're not seeing any return of the spring bloom. We're seeing basically the deep chlorophyll layer and the nephloid region, those are gone, and that's related to the spring bloom, to nutrients, and to this nearshore offshore filtering of material. We also see that the nearshore region is changing. We have some data from the 90s from the nearshore region, that from other projects that we're looking at, so we're going to do some nearshore work looking at that. But the nearshore isn't a real epicenter of production right now. Zooplankton biomass, on the other hand, isn't increasing or decreasing. That's probably balancing out some lower and up, top-down and bottom-up effects right now. And it's just not increasing or decreasing, but we're seeing recoveries of Daphnia, somewhat recovery of cyclopoids, no real change in limnicalinus. The nearshore and offshore zooplankton are fairly similar, but our mysis are low, and that is of some concern if it continues to stay that way. And if there's any questions at the top.